Hello friends, welcome to Learners Forum. So in last video we saw about the addition of binary, octal and hexadecimal. Now we will see about the subtraction of binary, octal and hexadecimal. So the first example given is 1101, 1011, two binary numbers. We have to perform subtraction. So let us start from the rightmost bit. So 1 minus 1 will be 0. Next, moving on to the next bit, 0 minus 1. So, since we have 0 which is less than 1, we have to make sure that we are doing a borrow here. So, from the previous bit, we have to get a borrow value. So, to perform this, consider the base value which is 2. Current value 0. So, 2 plus 0 will be 2. And in front we have to make sure that we are reducing by 1 bit. So 1 reduced to 0. So 2 plus 0 is 2 and 2 minus 1 will be 1. So this is how we have to perform. Next, 0 minus 0 is 0. 1 minus 1 is 0. So 0, 0, 1, 0 will be the value. Similarly, we'll solve the next example. So here we have 0, 1. 0 is less than 1. We have to borrow. So from the previous bit, reduce it to 1. That is, 1 is reduced to 0. And in the current bit, add the binary which is base 2 plus the current value which is 0. So 2 plus 0 will be 2 and 2 minus 1 will be 1. Next, again 0 is less than 1. So we have to make borrow again. So repeat the same step. So in the previous bit we have to reduce it by 0 now, and the current bit has to be added with the base value. So 2 plus 0. So 2 plus 0 will be 2. 2 minus 1 will be 1. Next, 0 minus 0 is 0. 0 minus 0, 0. 1 minus 1 will be 0. So 0, 0, 0, 1, 1 to the base 2 will be the answer. So this is how we have to do subtraction for the given binary number. Now we will see how to perform it for the octal type. So the given number is 731159 with the base 8. So we have to follow the same step but with a simple change. 1 is less than the base 9. So in front we have to reduce the 3 value as 2. And 1 has to be added with the base value which is 8. So 1 plus 8 will be 9. So 9 minus 9 will be 0. Next we have the value as 2 which is less than 5. So we have to borrow it again. So in the previous bit 7 has to be reduced by 1 which is 6. Next, in place of 2 we have to add the base value which is 8. So 8 plus 2 will be the value now. 8 plus 2 is 10. 10 minus 5 will be 5. Next, 6 minus 1 will be 5. So 550 will be the answer. This is how we have to perform octal subtraction. Next we will solve one more example. Given is a 5-digit number 36251276676. So 1 is less than 6. So we have to borrow again. So in the previous bit we have to reduce 5 by 4 now. And instead of 1 we have to add the base value which is 8 plus the current value which is 1. So 8 plus 1 will be 9 and 9 minus 6 will be 3. Next again 4 is less than 7. So we have to borrow again. So instead of 2 reduce it by 1. So we will have 1. And instead of 4 we will add the base value which is 8 plus 4. So 8 plus 4 will be 12. 12 minus 7 will be 5. Again 1 is less than 6. So borrow again. 6 is reduced by 1 which is 5. And in place of 1 we have Add up with the base value 8 plus 1. So 8 plus 1 is 9. 9 minus 6 will be 3. Next again 5 is less than 7. So the previous bit has to be reduced by 1. So 3 reduced by 1 is 2. In place of 5 we will have 5 plus the base 8. So 8 plus 5 is 13. 13 minus 7 will be 6. Again 2 minus 2 will be 0. So this is the subtracted value for the given octal number. Similarly, let us solve it for the hexadecimal now. So to perform hexadecimal subtraction, we need to know the base value, that is A, B, C, D, E, F and the corresponding representation. So if you write the values while solving the problem, you can just relate it easily. Now let us solve the first example given is EF2 A4E. So the first value 2, which is less than E is 14. So 2 is less than 14, we have to make borrow now. So in front of the value f has to be reduced by 1. The value of f is 15. So after reducing 1 it is e. So in place of 2 we have to add the base value which is 16. So 16 plus 2 will be the value which is equal to 18. So 18 minus e. E is 14. So 18 minus 14 money will be 4. Now e, the value of e is 14. So 14 minus 4 will be 10. 10 is represented by the value as A. So it is written. Next E. E is 14. 10 which is A. So 14 minus 10 will be 4. So 4A4 will be the answer. Let us solve one more example. Given is FCDD to FEE. So D has a value as 13 and E has the value as 14, which is less. So we have to make borrow now. Instead of D, reduce it by one value which is C, that is 12. Next in place of D, we have to add the base which is 16 plus D value is 13. So 16 plus 13 will be 29 and E is 14. So 29 minus 14 will be equivalent to 15. So the value of 15 is represented as F. So that we can write here. Moving into the next bit, C. C has the value 12 and E is 14, which is less again. So in previous bit we have to make reduction, which is B now. C has the value as 16 plus C value is 12. So 16 plus 12 will be 28 minus E value is 14. So 28 minus 14 will be 14. 14 is represented as E. So we can write it E now. Next B and F. B is 11, F is 15, which is less. So again we have to make borrow. Instead of F we can take it as E by reducing by one bit. Next in place of B we have 16 plus B value which is 11. So 16 plus 11 will be 27 minus F value is 15. So 27 minus 15 will be 12. 12 is represented as C. So we can get C. Next E value is 14. 14 minus 2 will be 12. 12 is represented as C. So CCEF will be the equivalent answer after performing subtraction. So this is how we have to perform subtraction for binary, octal and hexadecimal. The procedure is same. We have to just change the base values, which is 2 for binary, 8 for octal and 16 for hexadecimal.